Hi and welcome to this episode of TK Physical Education, where we'll be looking into movement analysis and covering the associated topics, these being levers and planes of axes of movement. We'll also be looking at key exam questions and using sporting examples to illustrate these points. First, let's have a look at levers. A lever is a simple mechanism which allows movement to take place, and this can be found all over the body, more specifically at the synovial joints, these being joints that allow movement such as the elbow, the shoulder, the neck, hip, knee, any joint that allows movement in the body. These are very important for us in sport because they allow us to run, jump, turn, move, all the necessary actions. Now levers can be categorised in three different ways. The first being first class levers, we then have second class levers and third class levers. All these levers are different in the way they are arranged. However, they have similar features. For example, all levers will have a fulcrum, this being the synovial joint or turning point where the movement is actually being allowed. They will also have an effort. This could be the muscle, which allows the energy for that movement to take place. And finally, each lever will have a load, this being the body part which needs to be moved in order for it to be an effective movement. Let's have a look at these levers in more detail.
First class levers are structures with the fulcrum between the load and the effort, like in a seesaw. These are rare in the body, but can be found at the neck. The fulcrum is the neck joint, the effort is the trapezius muscle, and the load would be the weight of the head. Second class levers have the load in between the effort and the fulcrum, like in a wheelbarrow. The example would be the gastrocnemius muscle working as the effort, the fulcrum at the toes, and the load being the weight of the entire body. Third class levers are the most common. This is when the effort is between the load and the fulcrum. A fishing rod or a shovel works with this mechanism. The fulcrum of the elbow joint is behind the bicep muscle, which works as the effort to pull up the arm's load. Levers can have mechanical advantage or mechanical disadvantage. When the effort arm is further from the fulcrum than the load arm, we have mechanical advantage and it's easier to lift. When the load arm is further from the fulcrum than the effort arm, we have mechanical disadvantage. First class levers can have either mechanical advantage or mechanical disadvantage. The rower must pull the oars far away from the fulcrum to ensure they have some advantage. Second class levers always have mechanical advantage. This is necessary to lift the entire body with just the gastrocnemius muscle in the long jump. Third class levers always have mechanical disadvantage. Although the levers have to work harder, the large bones of the limbs make up for this disadvantage. They can still produce large efficient movements.
The next topic to be covered is planes and axes of movement. This is the key terminology used to describe a movement in any sporting action. A plane being the channel or surface in which a movement can move in, and an axis being a central point or line in which we can turn around, whether that be in a horizontal or vertical direction. Let's look at the planes and axes in a bit more detail. Now, in order to describe a sporting technique or rotation, it's very important that we can understand exactly how these axes and planes work and how they work together as a pair. Now, the first axis is the sagittal axis. Now the sagittal axis actually runs directly through the centre of the body, basically through the belly button, and allows us to rotate around that central point, basically in a cartwheel motion. If you're moving in this motion, you'd be moving in the frontal plane, which is to the side. The next axis is the frontal axis. This allows us to move in a forwards and backwards rotation, like as if you were doing a forward somersault or a backward somersault, and this moves in a plane called the sagittal plane. The final axis is called the vertical axis. This runs through the centre of the body from top to bottom and basically allows us to move in a 360-degree rotating action. Now, if you're moving in a 360-degree rotation, you would be moving in what's called the transverse plane.
tips to remember the information. Levers can be identified easily by what's in the middle. First class levers always have the fulcrum in the middle, second class levers always have the load in the middle, third class levers always have the effort in the middle. It doesn't matter which way round the lever works, these things will always be the middle item. We can remember the levers using this rhyme, 1, 2, 3, FLE. FLE signifies the middle item of the lever. First class levers can either have mechanical advantage or mechanical disadvantage depending on where the fulcrum is placed. Second class levers always have mechanical advantage. Third class levers always have mechanical disadvantage. First of all, remember that the sagittal axis runs through the belly button, the frontal plane is to the side. The frontal axis is in line with the frontal plane and the sagittal plane is in line with the sagittal axis. The odd one out is the vertical axis and the transverse plane, with the vertical axis running from top to bottom.